Use the integral test to determine whether the series is convergent or divergent. Well, first of all, let's just run through the requirements for when you can use the integral test and make sure we meet those here. So when the integral test works nicely is if you looked at a continuous function that had this as its positive integer terms, and you knew how to integrate that, then we could use the integral test, but the requirements are it needs to be continuous, and we see that this has a discontinuity at -3, but we are going to be starting here at 1 and doing the positive integer, so it is continuous on what we will be looking at. So we will be looking at here going from 1 to infinity, and it's continuous on that interval. And so I'm going to write it as 2 square root of x plus 3 dx. Second requirement, terms need to be positive. We can see that this is always positive. Third requirement, the terms need to be decreasing, and we can see here that as we get larger with x, the denominator gets larger and therefore the fraction gets smaller, so it is decreasing. So we can use the integral test, and so we're going to compute this integral. So let's go ahead and think of this as the limit as b goes to infinity, integrating from 1 to b, and we'll put this 2 out in front, and we're going to write this as x plus 3 to the minus 1/2 dx. Now as we look to integrate this, then we would use the power rule in reverse, so we need one higher power here. So that's going to be, we still have the 2, and we're going to have x plus 3 to the one higher power, which would have been a 1/2, and that 1/2 would have come out in front, but here we see a 2 out in front, so actually that we must have had another 2 there, so that when we bring that half out in front, that will cancel with this 2 and leave us another 2. Now thinking of the chain rule, the derivative of what's inside is 1, so we're okay there. So now we need to evaluate this from 1 to b, and I left this off. It should have had the limit as b goes to infinity here. So let's express that a little bit better as we evaluate. So limit as b goes to infinity of 4, and this is square root of b plus 3, and then we have minus 4 square root of 1 plus 3, which is 4. So now as we look to evaluate this, we see that this is just a number, this is just -8, but looking here as b goes to infinity, the square root of something going to infinity is also going to go to infinity. So this does not converge, this integral diverges, and then by the integral test then, if the corresponding integral diverges, so does the series.